Okay, so now with the calculations of the fault current, we are ready to perform the grading and the setting of the relay. So when we look at bus C, because bus C is the load bus C, if you look at bus C, right, then we notice what are the things that we need to set over here are the relays. Remember, we want to set the relay. Only relay are settable. There's no such word. Only relay can be set. And the downstream of the bus C here, these are not relay, these are fuses. So fuses are fixed in their nature of protecting the devices, meaning that they will burn out whenever certain current levels go beyond their tolerance. They will burn out. Simple as that. They cannot be set. So when we look at bus C, then we have to look at both above and below bus C. Above bus C, you have relay 1 and 2. Below bus C, you have fuse 1 and fuse 2. So when you look at bus C, only relay 1 and 2 can be set. But when you want to set relay 1 and 2, you have to coordinate relay 1 and 2 together with the fuses below them. Therefore, we have to look at the properties, the functions of the fuses. So we are given that fuse number 1 have a TMS 0.1 and T is 0.02 second, meaning that the time multiplier setting is 0.1 second and the reaction time is 0.02 second. What is this? We'll have a look at the equation later for determining the setting of the relay. And if not, if you go through the part 1 of the presentation slide that I mentioned earlier, then you will know what is DMS and what is T and what is extreme inverse and standard inverse curve, right? And F2 is the properties of fuse number 2, which has a TMS of 0.25 and a reaction time of 0.05 seconds. So just now remember when we calculate the fault at bus C, when you have two lines available, okay, when you have two paths available through C1 or C2, then the total fault current is 10.6 kA. But when you want to divide this fault into two of the line, it is 10.6 kA divided by 2, right? 10.6 kA divided by 2 is about 5.3 kA. And when you have fault with only one of the line available, either C1, either C2 or C3, then the fault experienced by the relay will be 9.33 kA. So now you compare. When you have double line available during a fault and a single line available only during a fault, which of the conditions that the relay will experience a higher fault current? It is the later one, which is the condition when you have only one line available during fault, which is 9.33 kA. So because 9.33 kA is larger than 5.3 kA, we use 9.33 kA in our setting of a relay. So we consider the highest fault current possible. All right. And then there's one more thing. One more thing over here is that the maximum load that these two feeder that can sustain, right, is only 400 amp. It's only 400 amp. So the IS, which is the setting, the current setting, which we will use in setting our in our setting curve, the extreme inverse curve, the standard curve, right? So IS that we have to consider now is either 400 or 450. 450 is obtained by taking 400 divided by 0.95. Why divide by 0.95? Is so that the relay must not be less than drop off or pickup ratios of 0.95. Okay, this is one of the consideration. Okay, the standard that we adopt here. So it's either 400, 450, or the relay must be 3 times larger than the fuse rating, which is 3 times multiply 160 amp, because the fuse rating here is 160 amp, right? 160 amp. So when you are coordinating relay and fuse, these are the three conditions, the special considerations that you need to consider. Either the first one, 400, is the feeder, the current at the feeder can withstand. 450 amp is divided by the ratio, and then 480 amps setting is due to the requirement that the relay must be 3 times larger than the fuse rating, which is 160 multiplied 3. Okay, so the IS that we can consider over here is either 400, 450, or 480 amp over here. So